Hey everybody, welcome back to another fun and exciting pre-algebra class. Maybe you're looking at the things around me going, what's going on here? Well, I told you that our house was under construction, and guess what? They finished the upstairs, so I have moved my office studio upstairs, and so, hey, I'm moving up in the world, literally moving up in the world. Do you get it? Moved upstairs. Come on. You're not even gonna laugh a little bit. It was a little bit funny. No, okay, I get it. So, yeah, things have changed a little bit, but the lessons are gonna stay the same. Just a little bit different background. This will give you something to look at here for a few lessons. Maybe keep your attention here. Well, we are starting off in chapter number 11 today, moving into the second to last chapter in this book. So we're almost finished. Keep working hard. You're almost done. This chapter starts on page 504 in your book, so you can turn there at page 504. All right, let's go ahead and look down here at the screen, and you will see that we're going to be talking about the square root in this chapter. What is a square root? Well, a square root is, and probably a lot of you kind of have a concept of what a square root is, but a square root is when there's a factor that can be multiplied by itself, and that equals the original number. Okay, so you're like, what in the world did you just say? Okay, well, for example, the number 9 has a perfect square root. If you take 9 and you say, okay, 3 times 3 equals 9. Notice when I take a factor. A factor is 3 here in this case, and I multiply it by itself. 3 times 3. When it gives me the original number, that is a square root. So some students are like, well, okay, well that makes sense. So what about 12? 12 has a square root, right? So 12 is 3 times 4. No, 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 no. That doesn't work. Why not? Because it says that it needs to be multiplied by itself. 3 and 4 are two different numbers, right? 3 and 4, that doesn't work. 3 and 4 are not the square root of 12. There is a square root of 12. So if I get out my calculator and look, I can actually take the number 12 and hit the square root button on my calculator, and it will tell me that the square root of 12 is 3.464106161, blah, 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 blah. Now, here's what that means. It means the square root of 12 is not what's called rational. It has to be rounded off. If you look at this number is actually rounded off. Okay, so this is a big long number, and we round it off after the 5. There's actually more. If the calculator could show more, that number keeps going. The square root of 12 is what's called irrational. Okay, or in other words, it doesn't really make a lot of sense. The square root of 9, however, is what's called rational. Rational means that it comes out to a whole number. Irrational means it doesn't come out to a whole number. So when you're doing this, we're actually going to learn a lot of the rational square roots here a little bit later in the lesson. But when you're doing this, if you ever get a rational square root, you can actually solve it out. So if we got the square root of 9, we could solve it out to 3. But if we get the square root of 12, then we can't really solve it out because there is no rational, if you will, square root of 12. It's irrational. So you would just leave it as the square root of 12. We will find different ways that we can reduce that square root, but in that case, we would have to leave at least part of our answer as a square root because it's not rational. We'll get into that more. Just wanted to kind of whet your appetite for what rational and irrational means. All right, let's go ahead and look down here at this. This is really important right here. When we are dealing with square roots, this is what's called a cube root because it's a 3, just like when we take a number like 3 with a little 3 up here, we said that was 3 cubed, right? That's what that 3 means. So the same thing is happening when we do the cube root of something. So if we put a little 3 there, this number is called the index. the index. This sign right here, it kind of looks like a division sign, right? So there's your division sign, and then it's got this kind of this weird thing out front. But this sign right here is called the radical sign. Okay, so that's a radical. And then we have right here, this number underneath is called the radicand. In this case, our radicand is 27. And then our index is 3, and then we have the radical sign. Make sure that you know these key words right here, because you're going to hear me say those quite a bit. You're going to hear me refer to the index. You're going to hear me refer to the radical sign. You're going to hear me refer to the radicand. All right, let's look down here at the cube root. I kind of talked a little bit about what it is, but I wrote it here, the factor that when multiplied by itself 3 times. Remember, the square root is when you do it 2 times. The cube root is when you do it 3 times. So let's check this out right here. What is the cube root of 27? Well, watch this. The cube root of 27 equals 3 times 3 times 3. So the cube root of 27 is 3. Because watch what happens. 3 times 3 is 9. 9 times 3 is 27. There's our original number. There's our original radicand. And so the cube root of 27 is 3. That might have just like blown your mind right there. Don't worry about it. We will kind of circle back to that as we're going through some of these different things. But I just wanted to show you cube roots right now so you kind of had an idea of what those are. All right, let's talk about how to write and read these things. So when we're dealing with the square root, you would have an index of 2. Now, here's the cool thing about square roots. You don't even need that index. So we can just go ahead and we can just remove that 2. We don't need it. This is like the same concept of saying, x to the first power. We don't need that 1 right there. Or it's like saying 1x. We don't need to say 1x. We don't need to write it. This is like saying x over 1. We don't need to write the 1 there. So all we have to write is x. In this case, the understood index is 2. But we don't need to write the 2 because everybody knows if there's nothing there, we're talking about a square root. There really is no first root because the first root of the number is just the number itself. So you wouldn't have like the first root of 4. The first root of 4 is just 4. So you wouldn't ever do that really. So you'd put a 2 here. The square root of 4 is... I'll just go ahead and solve that. It's 2. Why is it 2? Because 2 times 2 equals 4. So that's how we would say that. Square root of 4. Remember, we don't have to put an index there. It's an understood square if there's no index showing. The next one here, we have what's called the cube root of 8. And that's how we say that. Cube root of 8. I guess you could also say the third root of 8 if you wanted, but nobody really says that. If there's a cube, they just say cube root of 8. But technically, you could also say the third root of 8 if you wanted to. And let me show you something cool. The cube root of 8 is also 2. Why is that the same answer? Look right here. We got the exact same answer. So the square root of 4 is 2 times 2, basically, or the square root is 2. Now watch with the third root of 2. 2 times 2 times 2, remember, because we're doing it to the cube, is 2 times 2 is 4 times 2 is 8. Okay, there's our original number we got when we did that 3 times. So the cube root of 8 is 2. This last one down here at the bottom is the fourth root of 16. And that's how you would say that. There's no fancy word for fourth root, fifth root, sixth root, seventh root. Like we have square root for the second root, right? We have cube root for the third root. But then once we get to 4, there's no fancy word for it. We just say the fourth root, okay? So we say the fourth root of 16. What does that mean? It means the same number multiplied by itself 4 times. This is crazy. Watch. This also equals 2. Some of you are like, you're just like, you don't even know what just happened right there. Okay, watch this. 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 times 2. 4 times 2 is 8 times 2. 8 times 2 is 16. There's our original number. We're back to the original number again, just like we have in the last two examples. So 2 is the square root of 4, 2 is the cube root of 8, and 2 is the fourth root of 16. Complicated? Yes. Mind-blowing? Yes. But I think when you work with this long enough, you keep practicing these, it will start to make just a little bit more sense. All right, I talked about this just a second ago, but I talked about the concept of squares and cubes and them being perfect, or what we called rational, and then what we called irrational. Okay, so when we tried to get the square root of 12 earlier, it didn't come out, it wasn't rational. Okay, so we'll talk about those in later lessons, but for this lesson right here, we want to focus on what's called the perfect root. Now, there are only a few perfect roots. There's only a few numbers that have perfect squares. The first perfect square right here is the number 4. Why is the number 4 a perfect square? Because 2 times 2 equals 4. Okay? The number 9 is a perfect square because 3 times 3 equals 9. The number 16 is a perfect square because 4 times 4 equals 16. The number 25 is a perfect square because 5 times 5 equals 25. I think you see the pattern forming, right? So if we go to 36, it's 6 times 6. 49 is 7 times 7. 64 is 8 times 8. 81 is 9 times 9. 100 is 10 times 10. 121 is 11 times 11. 144 would be 12 times 12. You could keep going with that. 13 times 13, 14 times 14. And you could keep going all the way up till a million times a million. I mean, you can keep going. There's no end to the perfect roots. So the only ones that I really am going to really emphasize and kind of force you, if you will, to memorize are these guys right here, okay? 4 through 144, or in other words, 2 through, this one's 12 times 12 equals 144. So you need to know the 11, the 10, the 9, the 8, the 7, the 6, the 5, the 4, the 3, the 2. And you say, well, why don't I need to know the 1? Okay, well, 1 times 1 equals 1. Okay, so there you know. You already know the ones. You didn't even know you did. All right, so the square root of 1 is 1. Hey, the cube root of 1 is 1. The fifth root of 1 is 1. Okay, because 1 times 1 times 1 times 1 times 1, 5 times, is, guess what? 1. Okay, so 1 is kind of its own deal. It doesn't ever change when you square root it, cube root it, fifth root it, doesn't matter. So make sure that you know those roots there, those perfect roots. What does perfect mean? It means it comes out to an even answer, okay? So 2 times 2, 4. 3 times 3, 9. It keeps coming out to what's called whole numbers. All right, so let's talk about these ones over here. Let's talk about these cubes now for a second, because these are a little bit more complicated. The cube, the first cube that we'll want to know is we want to know the number 8. 8 is the cube of 2 times 2 times 2. So 2 times 2 times 2 equals 8. Okay. The next cube that we're going to want to know is 27, because 3 times 3 times 3 equals 27. The next cube that we're going to want to know is 64, because notice 4 times 4 times 4 equals 64. The next one that you'll need to know is 125, because 5 times 5 times 5 equals 125. Notice that these numbers are getting big fast, right? So these ones, we're only at 25 here with the squares, but we're already all the way up to 125. I'm going to kind of stop there as far as like what I'm really wanting you to know and memorize with the cubes, but you should be able to figure out the next one, right? Because we got 125 here, so you should be able to go to the next one. 6 times 6 times 6 is going to equal what? Well, it's going to equal 6 times 6. So you can do these ones on a calculator if that kind of saves you a little bit of time right there. So 6 times 6 times 6, do that 3 times, and that equals 216. I'm not gonna, so 216, 216. I'm not gonna force you to memorize that one. 7 times 7 times 7 would be the next one. You really only need to know these first four with the cube. So 2, 3, 4, and 5. Know those with the cubes. With the squares, you should know all the way to 12. And you're gonna thank me later. Okay, when you get to algebra class, you're gonna say, "Oh, thank you, Mr. Steve. I really now understand why you made me do those." Okay? So that's really all that I have for you in this lesson. I didn't finish the lesson, so we're going to do a B part to this lesson. So we're going to go through the kind of the next little bit, but there's a lot of practice problems that kind of focus on that first part. There's a couple charts where you're going to write in your perfect squares in the book there. So take time, focus on those perfect squares, make sure you know what they are so that we can know, and for the future lessons that we'll be doing, and then especially for when you get to algebra class, this is going to be super, super important for you. All right, that's all I got for you. Hope you have a good one. We'll see you later. Bye-bye.